Starting out with something real simple today, order of operations. Now, it might be new to some of you. Y'all seen this before, right? And you know it stands for please excuse my dear Aunt Sally. Have you heard that before? Well, this ain't right. I mean, it's never been right. They teach it that way to you in middle school and even in Algebra 1 in the old system because they didn't think your brain could handle what it really stands for. It stands for a G. And come on. And G means grouping symbols. Any type of grouping symbol is the first thing. Would you all agree a parenthesis is a type of a grouping symbol? So types of grouping symbols. Grouping symbols are obviously parentheses. So parentheses, even brackets are grouping symbols. And things we're not so used to, absolute value bars are grouping symbols. Have you seen the absolute, like if I want the absolute value of 3, which we'll do a lot of absolute value bars are grouping symbols. And even a fraction bar. Do you see how I have this nice little fraction bar right here? And you see in the numerator itself is a group, and the denominator is a group. And according to the order of operations, we need to do this first, because that is in a group. That is in the numerator. We need to take 3 plus 5 and add that together and get 8 before we do any dividing. So G is grouping symbols. E is any kind of exponents. Multiplication and division are on the same level, and you work from left to right. We work from left to right on multiplication and division. Multiplication does not have to come before division. We'll just work from left to right, as we'll see as we go through this, and then finally add and subtract. So I know it's just simple. We're trying to knock the cobwebs off on the first day of school. Nothing too complicated, so let's use the order of operations. First, are there any grouping symbols in this bad boy? Yes, so we got to do what's in there. But we don't just kind of half-ass it. We do the real thing. We write down this. The 14 did not get affected, and 6 divided by 2 becomes a 3. Correct? That's what it was. And now the only thing left is addition, so we can add those together and get a 17. That's the final answer, and I circled it. I want you to notice something. This started as an expression, meaning there are no equal signs involved. Do you see my work? Did an equal sign show up anywhere? I did not put this. This is what a lot of people do, and they just make an equal sign show up and turn it into an equation. No, no, no. If it starts with no equal sign, it ends with no equal sign. Sound cool? Let's move to the next one. Inside the grouping symbols is where we start first, right? We got to do the 3 plus 2. All right, we don't need that exponent yet. We got to do grouping symbols first. So we have 11 minus 5 squared. You with me on that? Then what's the next thing we got to do? Exponent. So what's 5 squared? So we got 11 minus 25. And then finally, try to exercise that brain. I don't care if you use a calculator per se. It's the first day, but 11 minus 25. It's a 4. What you really do is take the bigger number minus the smaller number, and you get a 14 out of that situation. And then which one of these was the larger of those two numbers? Isn't 25 larger than 11? Attach the sign that was involved with it. Doesn't the 25 have a negative involved with it? So that's a negative 14. So when you're doing a subtraction problem of different signs, take the big guy minus the small guy, get that, and then attach the larger sign is what it's called. Next! What do you want to do first in here? We got 9 times the quantity of 3 squared plus 6. First thing, Chelsea, what would you do? 3 squared. Because it's in the grouping symbols. We do have grouping symbols. You got to look what's inside of there and then follow the order of operations. There's addition and exponents in there. You must do the exponents before you do the addition. So we're in the group, and then we look what do we do by a priority. So we have 9 times 9 plus 6. Y'all okay with where that came from? Are there still grouping symbols? So we got to do 9 plus 6. Because they're like terms in there. We don't do the distributive property. You could do the distributive property, but these are like terms. You do the distributive property when you have stuff like this. Like you see how in the parentheses there's nothing you can simplify. You can't take 9 plus x because they're not like terms. So since the 9 and the 6 are like terms, you add them together and you get 15. And you got 9 times 15. If you got a calculator, go ahead and get it out because we'll need it. You know, but you can punch that in. You can think of it like this. 9 times 10. You all know what 9 times 10 is? 90. 9 times 5. What's 9 times 5? So add 90 and 45 together. And you get 135. A lot of tricks. The more you do math, the more tricks you learn. And I know exactly what you guys did all summer. You practiced your math problems, right? It's like, I love math. Next guy. Holy crap. There's a lot of things going on. Take it one step at a time. First, are there grouping symbols? Yes, there are parentheses. So we got to look in there. So here's some stuff in there. There's addition, there's an exponent, right? We got to do the exponent first. So it's 2 to the third power. I know it's been a summer, so that means 2 times 2 times 2. Take it times itself 3 times in a row. What's 2 times 2? Times 2. So we really have 5 plus 8. And I'll let us skip a little bit of steps right here. Can we kind of see that this is 5 plus 8? If you need to do this, do it. But I would say, I would say if this was, come on, pen. If I was doing this problem, I would have wrote this down. 13 squared minus 25. Do you see how I kind of did that in my brain already? And I also did this in my brain. It's a 5 squared. It would take you a long time to do every little step at a time. And you've got to let me be the pace guide, because I am very good at math and you are still working on it. I want to know how comfortable you are at skipping steps like that. So you just kind of, with your facial reactions, you know, it's like, I don't like that. But y'all cool with what I did. 5 plus 8 is 13, and I already did the 5 squared. It turned into a 25. Now what's 13 squared? 169. Take away 25. And like I said, if you want to punch that in, that's fine. And it turns out to be 144. Now, I do know how smart your calculator is also. You could take this and punch it in your calculator. And I could care less. I don't care about 144. I hate 144. Who cares? That's the answer. I don't care. I want to see this. I want to see the work, right? So if you're just giving me nothing but answers, that's when you and I are going to have to learn. That's not what I'm about. I am not about answers. I am about process. So show me the process. If I write it up there, you should write it down there. Let's try again. Holy crap. Do you see there's a fraction bar as well? That is a group in its own. And I personally work fractions kind of side to side instead of straight down. I don't care what you do, but I'm a side to side guy. So I do this. I'm looking at this all by itself. This is a group in its own. There is addition, there is an exponent, and there is division, right? 3 operations in there. What do I need to do first in this particular group? The exponent. So what's 2 cubed? So I have 16 plus 8 divided by 4. Cool with that? Then I'm going to look down at the other group. This is another group in its own. 1 minus 2 squared. What would need to get down in that group? 2 squared, which is 4, right? So you have 1 minus 4. All right, I'm not trying to do too much in my head. All I did was this in this group and this in that group. So far, so good. And then another fraction bar. Let's look at the numerator. There's addition and division. What needs to be done first? So I still have the 16, and 8 divided by 4 is 2. So far, so good. And then 1 minus 4 is how much? Negative 3. And then, of course, I'm going to the right, and I ran out of room, so I'm going to come back over here and get 18 over negative 3, which is negative 6. A fraction bar is just division. Feeling good? You and your partner, whoever's sitting near you, oh, I forgot to say that. You and your partner do this one. Please pause video and get that done. Let's see what the next one looks like. Go for it. Nice. On number 8, order of operations, there are groupings, but there's nothing to do in the group right there. This is multiplication. This is division, right? Which one should we do first out of there? Should we do the multiplication or should we do the division? We do the multiplication because you read from left to right. Cool? But I also want you to notice, isn't there a lesser operation in between those two kind of operations? Here was the multiplication and here's the division, correct? But between those, isn't there a lesser operation? So that's where you can kind of skip a step and say, this is really 42, right? Then you bring that lesser operation down, and you could do the 4 divided by 4. Also, if you want to, and 4 divided by 4 is 1 minus 5. Cool? Now, when do you have to truly follow that order? When you have something like this. 6 times 14 divided by 2. Do you see how you have a multiplication and you have a division, but there's no lesser operation in between those? You must do the multiplication before you do the division type of thing right there. Cool? But tricks you learn as you get older and more experienced. If there's a lesser operation in between them, you can do that. That separates, and then you can do that. So then you have 43 minus 5. Right? 43 minus 5, which is 39. 9. 2 groups. So I'll start with a fraction bar and clean up that numerator for me. Clean up the numerator. 6 plus 4 divided by 2. What you really got? 6 plus 2. I understand why you said 8, right? But 6 plus 2. And then I don't like to do those many steps in a row because it's like a division and addition. I don't like to do division then do it. I just like to write 6 plus 2. And then, oh no. Hopefully your comfort zone was comfortable with those first 8 problems. Now let's get a little uncomfortable. 4 divided by 6 needs to happen next. Would you agree with that? Which is 4/6 if you write it as a fraction. And that can reduce to how much? 2/3. Oh my goodness. Minus 1. This is where we're going to get messy now. And let me tell you, I don't like fraction buttons. Your calculators have fraction buttons. We don't need to use a fraction button. I'll teach you how to do it without a fraction button. So far, are we good with what we have? We really have 8 over 2/3 minus 1. To add and subtract fractions, you need a common denominator. Can we rewrite 1 with a common denominator? It's really 1 over 1, but we need it to have a denominator of 3, right? So what is this really? 3 over 3. So this guy can be scratched out a little bit. We really have 2/3 minus 3/3. Are we okay with what I did? I know it's first day of school. We all right? And then the denominator stays at 3, right? When you're taking 2/3 minus 3/3, it stays at 3. And you just add or subtract your numerators. We have 2 minus 3, which is a negative 1. 2/3 take away 1 is a negative 1/3. Comfortable? And that is so far so good, but it is not proper at all. You're not allowed to have a fraction inside of a fraction. So what we do is we rewrite it by doing multiplication. Instead of dividing by a negative 1/3, we can multiply by the reciprocal of this. Be careful, not opposite reciprocal, but reciprocal. What is the reciprocal of negative 1/3? Just flip it over is all you got to do. Negative 3. So we're going to take this green 8, this numerator, and instead of dividing by a negative 1/3, we're going to rewrite it as times negative 3. 8 divided by a negative 1/3 is the same thing as 8 times negative 3, which is, of course, negative 24. Okay with that? There will be a bunch of those type of problems on your homework. Like I said, I will help you. If you need some help, come in. We'll have a few more here. I can't remember if this one comes out nice or has some mess. It still came out nice. It was just messy in the meantime. So let's try the next one. Top group. What do we got to do first? The division. I don't even have room to go to the right, so I'm going to come work down instead. So I have 6 plus how much? 3 plus 15. All over. Is that a subtract or divide? Subtract. 8 minus 2, which is 6. Cool. And then I really have 9 right here. And then I'm going to go ahead and add 15 to it right away. When they're all the same operation, it's a plus and a plus and a plus. You use the associative property, community property. You can just add them all together. So 6 plus 3 is 9. 9 plus 15 is 24 over 6. And that comes out nice. What's 24 divided by 6? 4. Booyah! Evaluate each expression. Doing the same thing, but now we've got to substitute values in. So they tell you what A, B, and C, and D are. We've got to substitute them in the right place and then do the order of operations. So in the place, I will substitute in straight up. 8.2 is what A is. I'm going to put that in parentheses. I'm just a fan of writing multiplication with parentheses, especially when there are decimals involved. What's B? B is negative 3, so I'll put that in parentheses. Over D, is that a D or an A? D, which is a negative 1/2. So far, so good, right? So let's do the numerator. If you need a calculator, punch that in. 8.2 times negative 3. 24.6, negative 24.6, is that right? And then this is divide by a negative 1/2. Well, we can't have a fraction inside of a fraction. So you always keep the numerator the same, but instead of dividing by a negative 1/2, we're going to change it to a multiplication problem. And we will multiply by the reciprocal of the denominator. What is the reciprocal of the denominator? Not 2. Negative 2. Watch those signs. We're so used to opposite reciprocal because of perpendicular lines and stuff. We just, oh my gosh, I'm always taking the opposite reciprocal. Opposite reciprocal. It's just the reciprocal. So I got a negative times a negative. What will that turn out to be? Definitely positive. 24.6 times 2 is 49.2. And please circle your final answer. So sub in, and then follow the order of operations again. So let's sub in number 12. 5 times 6. C is 4, so I'm just going to put that in parentheses also. Minus 8, and B is negative 3. And then plus 10D. And then I'm going to close that parentheses, so let's use those in red. Lots of parentheses, the way I write that stuff down. But I kind of made those red ones a little bit larger because all of that stuff is really inside of that first group of parentheses that we had. So we've got to do all that stuff in there first. We'll save the 5 on the outside for last. So remember, we've got some multiplication involved in here, and we've got lesser operations in the subtraction and the addition involved also, so we can do a lot at one time. We'll still have the 5 times the parentheses. 6 times 4, 24. And then we've got another little group of stuff here that we're going to multiply together, but it's negative times negative, which will turn out to be positive 24. And then we've got another little group. It's a positive times a negative, so I'll have a minus, and half of 10 is how much? 5. So it's negative 5. Cool? Still got to do what's in the parentheses, though, because it's still a group. So 24 plus 24 is 48 minus 5. And 5 times 43. We can do that again, probably without a calculator. You know what 5 times 40 is? You know what 5 times 4 is? Well, then you don't belong here. 5 times 40 is 200, right? And 5 times 3 is how much? So 200 plus 15 is 215. Yep. Next. Did they not put the instruction? It's up there again, right? Okay, good. You have the numbers. If they don't have those, it's a good idea to rewrite them, but substitute in 13 for me. So 4 squared minus 1 over negative 3. And then you got minus D, but D is a negative 1/2, so you have minus a minus 1/2. And what's minus a minus? Plus. And minus a minus becomes a plus. Old things, you got to remember. And then we'll simplify. That becomes 16 minus 1 over, get yourself a common denominator, and add those puppies together. Change the negative 3 to negative 3 over 1, and turn them into common denominators. If this needs to become a 2, you would have to multiply it by a 2, meaning you have to do the same thing to the numerator, multiply it by a 2 also. So negative 3 over 1 is the same thing as negative 6 over 2. Right? I had to double both things, so that's what it became. Negative 6 over 2 plus 1 over 2 is how much? Negative 5 over 2. Cool? Not the final answer, but we're just working through the process. We cool so far? 16 minus 1 is over, and instead of dividing by a negative 5/2, you can't divide by a fraction. It's kind of against the rules. Change it to a multiplication problem. And I will let you figure out what you're supposed to multiply by. I do not want to divide by negative 5/2. I want to multiply by what? Not quite 2/5. negative. The sign's got to stay the same, right? The sign's got to stay the same. It's just the reciprocal. Cool? To multiply fractions, it's very, 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 very easy. You do not need a common denominator. You just kind of think of them both as fractions. Numerator times numerator. Do you all know what 15 times negative 2 is? Negative 30. And 1 times 5 is 5. 1 times 5 is 5. It is the first day of school. 1 times 5 is 5, right? So you got negative 30 over 5, which can be simplified to negative 6. Yep. You and the pal next to you, if you even have a pal, Hannah, get the next one done.
I do have a friend.
So please pause the video and get the next one done. 9 plus 32.8, right? Which is how much? Help me out. 81.8. Cool. Next, they get a little more challenging. That's why we're doing them all. You know, there used to be those practice worksheets where they were all at the same level. They get a little harder as we go, so that's why we get to do them all. Yay. Substitute in first. So 3 times 4 over a negative 1/2 minus a minus 3, so that becomes a plus 3. Cool? The minus 3 at the end is the trickiest part of it all. You got minus 3. Then we got to clean this up. So if you need to rewrite it, you can rewrite it. We don't want to divide by a negative 1/2. Instead, we want to do what? Multiply by the reciprocal of that. But this is pretty much as cut and dry as you can get if you can just see that it's 4 times negative 2. That says 4 times negative 2. Do you know what that is? So it's pretty simple, in my opinion. Out of all the ones, that's a little simpler. I'm fine with us being able to skip some steps. But if you have a problem with the process, do each step. But this was 4 times negative 2. And then negative 24 plus 3. All right? So far, so good? And then again, do these numbers, if you didn't have a calculator, do they have the same sign or do they have different signs? Different. Different means subtractive. Do you know what 24 minus 3 is? What's 24 minus 3? 21. Which one of these numbers is larger? 24. Attach its sign with it, and that's a negative 21. One more. All right, let's get that done. Sub in. A, 8.2, B, plus C, minus a minus again. So just get subbed in, then we'll work together. We cool on the substitution. Clean up the denominator down here. That's really how much? 1. So it's really 8.2 over 1, which is really just 8.2. Are you cool with that? If something's over 1, you can get rid of that. And then, since this is a decimal, I'm going to write it like this. I'll make that one a decimal. 8.2 plus 0.5. Right? 1/2 became a 0.5. Is that all right with you? And what is 8.2 plus 0.5? 8.7, baby. Yeah? Sweet. And then, of course, story time. These are very simple story problems. But, you know, it is amazing our ability to read. I am also not the world's best reader, you know, not the best reader, but read for information. So they're going to give us a formula, and they're going to tell us some information. We're going to do the same thing we did back here. We're going to have some information, and then we're going to substitute it into the right place and then solve for what's missing. So let's do that with this one, except it's in words. Here's the formula for number of reams of paper needed. Ream of paper, that's that big block of paper that you have, like when you put it in a copy machine. It's like, here is 300 sheets of paper. That's called a ream of paper. So the formula for the number of reams of paper, you need to print n copies of a booklet. So they just told you what n stood for. N is the number of copies. That is P pages. They just told you what P stands for. P stands for pages. Right? That's reading for information. And here's the formula. It's got an R in it also. Right after that, they tell you what R stands for. R is the number of reams. There should be no assuming of what the variables stand for. They are supposed to tell you what they stand for. So it says, how many reams of paper must you buy to print 172 copies in a 20-page booklet? So here's some numbers. 172. Let's figure out which variable it stands for. Does it stand for the R, the N, or the P? What do you think? What does the 172 stand for? It stands for number of copies, right? So I put an N underneath that personally. Like there's N right there. 172 is an N. And then 25-page booklet is which one of the left that we have, R or P? That is P, number of pages. So now I know two variables out of the three. I don't know R, especially when you can go back and reread and they say how many reams. Doesn't that mean you want to find what R is if you don't know how many reams? So let's substitute into this formula that they gave us right here. We just read from left to right. I do not know R, so it will still be there. Then there's an equal sign. N is 172, and P is 25, and over 500. And then we will still follow the order of operations. We will let the calculator give us some help, right? I will punch in 172 times 25, and I need your help with that. What is 172 times 25? 4,300. Thank you. Over 500. And then I will punch that in my calculator, and that will not come out very nice. So I'll say R is about 8.6. And I still got to solve for R. Like this is the algebra behind it. R is about 8.6, but to answer the question, you will need 9 reams of paper. 9 reams of paper. Lovely. Next, read through that bad boy, and then put some variables underneath the numbers they give you. But it's good to read through the problem. You and the pal can work together, and you can pause the video and get that done. A person, though. This doesn't work for everybody. What is this particular formula designed for? An 80-year-old man, right? Old dude, right? 80-year-old man. So you punch your weight and height and all that stuff, and it ain't going to give you the right number because you are not an 80-year-old man. So it says this, where W stands for the man's weight in pounds. So we got that. What is the BMR of an 80-year-old man? So the 80 has nothing to do with it, right? Because it's just telling you this is the formula you need. It's an 80-year-old man, qualifies for this formula, who weighs 170 pounds, isn't that W right there? So let's substitute in and figure it out. His BMR will be 12 times 170 minus 0.02 times 6 times 12 times 170. Where there was a W, I put a 170 in the place. That's all we did. Substitute in. Where there was a W, we did that. And now, let's punch stuff in. Calculator will help us. So BMR, 12 times 170. Help. 12 times 170. Didn't have a 12 times 170. What'd you get? That's what you got? That's too much. It's like my favorite game on The Price is Right. That's too much. 2040. You cool with that? Just working from left to right. And look at all these. All these right here. What operation is going on with all those? Multiplication. Isn't this a lesser operation? Multiplication, all this multiplication, but in between them, so the minus comes down, and we can just punch all of that in our calculator. It's multiply, 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 multiply. So 0.2 times 6 times 12 times 170. What did you get when you punch all that stuff in? Help me out, please. That shouldn't be right. 200 and what? You forgot a decimal spot right there when you punch that in. Cool? If your basic metabolism rate is negative, you are dead. Like you can't burn like negative amount of calories. You are just getting fatter and fatter and fatter regardless of what you do. I've got to really exercise. So you don't want it to come out negative. And then when you subtract those, what do you get? What's 2040 minus all that? Why don't I find my answer key and look that up? What you get? 795? So this old guy burned 1,795, about 1,800 calories a day just by laying around. Just by laying around. Cool? So that means he's got to eat that much to stay the same weight in his calories. Cool? And We need to do this one. I know I'd rather not do it, but we need to do it. It's been some old school. So A, B, and C. For a science experiment, Sarah counts the number of breaths needed to blow up a beach ball, right? Beach ball. You blow into it, right? She's got a formula. How many breaths does it take to blow this thing up? She will then find the volume of the beach ball, because isn't a beach ball a sphere, right? And you're filling it up with air, the space inside, so that is volume of it, in cubic centimeters, and then divide by the number of breaths to find the average volume per breath. So part A, her beach ball has a radius of 9 inches. Good information. She converts the radius to centimeters using this formula, where C stands for centimeters and I stands for the length in inches. How many centimeters are there in 9 inches? So they give us a number right here, 9. What does 9 go in for in this formula? Does it go in for C or does it go in for I? 9's in inches, so 9 will go in for I. Let's do C equals 2.54 times 9. And punch that in our calculator and get an answer. And you should get 22.86. Is that right? Yes? What did we just figure out? The centimeters. What in centimeters? Well, yeah, that's what 9 inches. But what part of our beach ball are we talking about? The radius. That's the radius of our beach ball in centimeters. Cool. Part B. Here's the formula for volume of a sphere. 4/3 pi r cubed. Right? Watch out for that. Where V is the volume of the sphere and R is the radius. So they want the volume in cubic centimeters. Wouldn't it be nice to know the radius in centimeters if we wanted to do that? So we'll substitute this in for R. You going to the mall today, Billy? Right there in our formula. So volume, we do not know. That equals 4/3 pi times 22.86 cubed. Just sub it in. And this is a messy formula. You just take it one step at a time, and you follow the order of operations. And we're going to punch it all in our calculator, because that's how I taught my geometry kids to do it last year anyway. So grab your calculator, if you even have one. You should bring a calculator. I know maybe you were waiting to see what kind of calculator to buy, but please have one soon. What would you want me to punch in first according to the order of operations? I've got division, multiplication, a number, and an exponent. What should I punch in first? So I'll take 22.86 and take it to the third power, 22.86. And then you see this raised to, if you don't know how to raise it to a power, to the third power, and I got an answer right there. It's not very nice. You okay with that? So what I have done so far is I have figured this out. Right? It's some magic number that I'm not going to write down. But then isn't everything left like all kinds of multiplication and division? Right? So what I do is I take that number in my calculator and I deal with this guy next. This, is that a times 4 or is that a divide by 4? Say this out loud for me, but don't say 4/3. What does this symbol mean according to addition, subtraction, multiplication, division? Doesn't it say 4 divided by 3 right here? So you're dividing by 3, but what does this 4 have to deal with? That's multiplication. We need to take this number that's in our calculator times 4 and hit equals. All right, so I cubed the radius, now hit equals. Then I took it times 4. So far, so good? Now I need to deal with this. Divide by 3. Right, so I will divide it by 3. So divided by 3 and hit equals between each step. And I've got that number so far. Cool? And what's left still, according to my formula? There's still something left. And what do I need to do with that pi? Divide by pi or multiply by pi? Take it times pi. So in my calculator, I'll take it times. And don't use 3.14. Use the pi button. That's on your calculator. Times pi. Commas belong in large numbers also. This is a large number. It needs a comma. 50,039.998444. I'm going to reread the problem, and maybe it tells me how to round that. Reread the problem, and what does it say to round to? To the nearest cubic centimeter. So does that mean like to the nearest tenth, to the nearest hundredth, to the nearest whole number? What does that really mean? Whole number, right? So let's round this to the nearest whole number. I'll show that to you. Please round that to the nearest whole number. 50,000 and what? And it's about now, it's not exact because we rounded it, 50,040 cubic centimeters. There's a label on it. I know Mr. Leo's not big on labels, and I don't know about Mr. Harris, but I'm big on labels. Okay? And so that's part B. Cool. Part C. Sarah takes 40 breaths to blow up the beach ball. What is the average volume of air per breath? So volume, you see this per. Per is a fancy word for division, right? So we need the volume. Do we know the volume? We sure do. It's that number right there. Divided by breaths. Do we know how many breaths she took? She took 40. So this number, which I will retype, I'm not going to use that rounded number because they told me to round that in the previous one. I will take that 50,040 and divide it by 40. And get that. 1251. And it's approximate, though, because we used the rounded number to figure this out. It doesn't mean that's exactly what she did. About 1,251. Now, label. Does that mean she blew into this thing 1,251 times? That's a heck of a beach ball if you got to blow into it over 1,000 times. How many times did she blow into it? 40 times. What's this number represent? The volume. So it's the volume, and the label on the volume is really how much? Cubic centimeters per breath. It's just what we just did right here. It was the volume, which was cubic centimeters, over breaths. So it's cubic centimeters over breaths with a H. Okay. First lesson. It was not easy, and it was not hard in the meantime. There was a lot of things to knock the dust off the brain, the fraction inside a fraction, and etc.